All right, we're going to start the second part of 3.8 here, and we're going to start off by trying to find the derivative of the natural logarithm, okay? So if we look at that, what we're trying to find is the derivative of the natural log of x, that. And we want to know, what does that equal? Well, we can start off by saying y equals the natural log of x, and we don't know how to take that derivative, but we can invert the function. If we raise both sides to, or we raise both sides so they're both the exponents of e, we get e to the y equals e to the ln of x, which is just e to the y equals x. Now this, we can do an implicit differentiation of, and we'll get e to the y times dy dx equals derivative of x is just 1 times dx over dx, and that goes to 1. So what we ultimately have right here is, we have e to the y times dy dx equals 1. That tells us that dy dx equals 1 over e to the y, and we know from right here that e to the y equals x. So I can replace that e to the y with an x and get 1 over x. And to sum it all up, we just found that dy dx equals 1 over x. Okay? And there's a result. We could have, instead of that, we could have done an or what we could have done was said f of x equals e to the x, and therefore f prime of x equals e to the x, and the inverse function's derivative as a function of x is 1 over f prime of f inverse of x, right? That was what we were just doing. And so this is just 1 over f prime evaluated at the natural log of x, because that's the inverse of e to the x, which means this is 1 over e, right? This is f prime right here. Oops, I should have put a circle on it. This is f prime right here, so it'll be e to the x, which is, in this case, ln of x, so e to the ln of x, and e to the ln of x is just x, so this is 1 over x. And so we get the same thing either way we do it. All right? So if we can go ahead and combine this with the chain rule, we get this right here. The derivative of the natural log of x, or natural log of u, assuming that u is a function of x, is just 1 over u times the derivative of u, where u is a function of x, right? U is a function of x. Kind of like if we were doing d dx of the natural log of f of x, right? Maybe it looks a little better that way. 1 over f of x times d dx of f of x, like that. So if you like it better written that way, that's fine as well. But we're just using the chain rule right there to do that. So let's take a look here. Let's find the derivatives of these things. So what we're going to do is just a little bit of substitution. I'm going to say, well, we can do the substitution or you can just do it flat out. I'm going to do the first one with substitution and then probably not again after that. So what we can do is say let u equal to x. Then we get du dx equals 2, and we also get that if u equals 2x, that gives us then that y equals the natural log of u, and then dy du is 1 over u, and since chain rule says dy dx equals dy du times du dx, where the du's will, basically cancel there, then we end up with 1 over u times 2, and u equals 2x, right? Right there. U equals 2x. So this just becomes dy dx equals 2 over 2x, which is just 1 over x in this case. There you go. All right, that worked out nicely. The other thing you could have done is just done the outer times the inner. We didn't have to actually do the substitution, so an or. If you're more comfortable with outer times inner, this just becomes, the derivative just becomes 1 over 2, not 2u, 2x times, that's the outer derivative, times the inner derivative, the derivative times derivative of 2x, right? Which is just going to equal, so is just going to equal 2 over 2x, which is just 1 over x as well. So whichever way you're more comfortable with, you go ahead and do that. Do it whichever way you like more. I'm going to do this next one, and then after that I'm going to leave the ones after this for you to try. And in this one I'm just going to do derivative of outer times the inner. So the outer derivative, so outer derivative is 1 over x squared plus 3. Right, I just grabbed what was in there, and then I have to do times the derivative of what's in there. And so the derivative of what's in there is 2x, and the derivative of the 3 is 0, so there you go. 2x over x squared plus 3. Okay, and that's it for that one. And again, you could do the substitution if you think that's easier, like I did right here, or you can just do, inner outer chain rule, whichever you're more comfortable with. Here, I'm going to leave these two for you to try. Take note of the natural log. You can actually, you could actually do like this of the natural log of the square root of x squared. That actually is equivalent to the absolute value, because when you square the number, you get rid of any negatives, and then you take the square root and you go back, like if it's -4, the absolute value of -4 is 4. Well, if you do -4 squared, you get +16. If you do the square root of 16, you get 4. So you always end up with that positive version. So try doing it with that replacement right there, okay? And then I'm going to leave this other one for you to try as well. And also don't forget the square root sign is to the 1/2 power is what that's meaning, okay? So give those a try, and then look in the notes for where I answered these. I'll write them out for you. All right, the derivative of a general exponential function. So let f of x equal a to the x, where a is a positive constant. So let's take a look at this. Let's have a to the x, and what we can do is make this equal to e to the natural log of a to the x, right? Because e to the natural log of b is just b, right? And so if we take the e to the natural log, they kind of cancel each other out, and you're left with just x. We have this little exponent up here, which, if you remember, means we can pull that out in front, and we'll get e to the x times the natural log of a, just like that. And now, if we do the derivative of a to the x, we're doing the derivative of e to the x ln a, and the derivative of e to the x, we're just going to chain rule this, right? This gets chain ruled into e to the x times ln of a times the derivative up there. So we did the outer derivative, now we have to do that derivative of that little part up in there. And so the derivative of x times ln of x is just ln of a, right? Because the x becomes 1, and the natural log of a is a constant, positive constant, so that just means that the natural log of a is a constant. And so what we can do then is switch this x back up to the exponent there, so it becomes e to the ln of a to the x times ln of a, and then e to the ln of a to the x is just a to the x. So this becomes a to the x times ln of a. And there you go. If we combine this result with the chain rule, right here. Then we get the actual rule that we should be following. Just like before, if you prefer it to be written this way, this would be a to the function f of x, and that's going to equal a to the f of x, right, times the natural log of a, right, that's what we got, times the derivative of the function. So that's d dx of f of x. Okay, if you prefer it written that way. All right, so let's try some of this. Let's go ahead and try the next one. We've got find the derivative of d dx of 3 to the x. So that's just going to be 3 to the x times the natural log of 3. And then times, if we wanted to do the chain rule, times the derivative of the exponent, which is just dx, but that's just 1. So it's up to you if you want to write that or not. All right, how about the derivative of 3 to the negative x? Well, that's going to be 3 to the negative x, right, times the natural log of 3 times the derivative of negative x, like that, right? And so this just derivative of negative x is just negative 1. So this is negative 3 to the negative x natural log of 3. Okay, and if you wanted to try that one using substitution, then that's fine as well. We have these two here left to try. Note that this is 3 to the sine x power. It's not that. It's not 3 times sine x. And so take note that what this means is essentially, sorry, I should write this here. What you're doing is that you're letting y equal 3 to the sine of x right there, and you're taking the derivative of that then. Okay, so you want dy dx there at the end. So again, try these two with, try these two on your own after this is done. And again, don't forget square roots are to the 1/2 powers as you do that one, okay? And then again, look in the notes when you're done with this, after you've tried them, and see if you were able to do them, okay? So let's look here, the derivative of a general logarithmic function. Well, remember that change of base means that we can basically replace any log with a certain base to any other log. So something like log of base a to the x is equal to log of any other base that you choose, c of x, divided by log to that same base c, so you have to make sure you choose the same base for the top and bottom, of the previous base. So in this case, what we're doing is just choosing e for c. We're choosing a new base of c, a new base of e, and so natural log of x over natural log of a. And so that's one way you can always type these in. You could have also made it base 10, but we know how to do, as we were just doing back here, where was it? We know how to do, somewhere, we know how to do the natural log of x, the derivative of it. It's just 1 over x. So, go several pages back this way. This essentially turns this into a pretty simple log, right? We're going to do d dx of, log base a of x, but we're going to replace that with d dx of the natural log of x over the natural log of a. Well, the natural log of a is just a constant, so we can bring that out in front. 1 over the natural log of a times the derivative of the natural log of x. And we already know how to do the natural log of x. So this is 1 over the natural log of a times 1 over x, which is just 1 over x natural log of a, okay? So just like that, all we did is change a base and then just use our rule there, okay? So nothing too crazy. And you can basically use the chain rule to go ahead and extend this, And if it's a derivative of u, so what we can do is say the derivative of the log of base a of u, where u is a function of x, is just going to be 1 over u times the natural log of a times the derivative of u, right? And if you want that in the previous way, what we can do is with f of x's, you can do the derivative of the log the base a of f of x, function of x, if you prefer that notation. That's just going to equal 1 over f of x times the natural log of a times the derivative of f of x, like that. Okay, so whichever way. This is just a little more concise. Just you have to remember that u is a function of x. It basically just is f of x. Okay, so let's try and do some of this. So find the derivatives of the following functions. The derivative of the log base 2 of 5x. So this is, just as we're doing, it's the derivative of the natural log of 5x over the natural log of 2, right? So as long as you can remember to do this change of base, you don't really have to memorize this formula here, right? As long as you just do this change of base real quick, and I'm very big on that. Memorize as little as you have to and really try to understand. So if you already have to know how to do a change of base, then you might as well use it. So it becomes 1 over the natural log of 2 and then times the derivative of the natural log of 5x. So the derivative of the natural log of 5x is going to be doing the outer derivative is 1 over 5x times the inner derivative. Well, that's the derivative of 5x. That's a 5. So this just becomes 1 over x natural log of 2, because these 5s are going to cancel. Okay, and so there's our derivative of it. I want you to also note that on the previous page, what happened when we did, what if we did the derivative of the log base 2 of x, right? If we do that derivative out, what do you get? You get 1 over x times the natural log of 2, right? 1 over x times the natural log of 2. That's what's going to end up being. Well, take a look. This and this, those are the same derivatives. So we're saying the derivative of log base 2 of 5x is equal to the same thing as the derivative of the log base 2 of x. And how are these two things the same if they're totally different functions? Well, you have to remember that log of a times b is equal to log of a plus log of b. And so that means if we take log of 5x, it's going to equal log, and we do base 2, log base 2 of 5 plus log base 2 of x. And so this is just a constant. See, log base 2 of 5x equals a constant plus the log base of 2. And constants, when you take the derivative, so if we were to split it like this, if we were to split it like that and take the derivative, the constant term would just go to a 0. And we'd end up with taking the derivative just still of, the only part that would be left is the derivative of log base 2 of x. So just kind of keep that in mind, that those constants inside there are going to end up canceling out like that. So let's see here. Do I want you to try this one? No, I'm going to do this one and I'll leave the next ones for you to try. So let's go here. Let's do this. Log base 3 of 1 plus x ln x. So we can do substitution here, or we can just do derivative of outer times derivative of inner. So since this can become d dx of natural log of 1 plus x ln of 3 over ln of 3, like that, then what we can do is actually just do the regular derivative. We can leave the 1 over ln of 3 alone. It can come outside the derivative, times then derivative of just this part right here, this numerator part. And so the derivative of natural log is 1 over what's inside there, 1 plus x ln of 3. And then we have to do times the derivative of what's on the inside. So we have to do the times the derivative of what's inside that natural log right there. So times the derivative, I'll write this one for you, 1 plus x ln of 3, all right? And so now we have to do that derivative. We've got the same thing here, 1 over ln of 3 times 1 over 1 plus x ln of 3 times, now this derivative, well, the derivative of 1, that's a 0, plus the derivative of x ln of 3. Well, ln of 3 is a constant, so we don't worry about it. We're just doing the derivative of x and carrying that ln of 3 along. So this just becomes ln of 3, all right? And so now we have an ln of 3 here and an ln of 3 here. They cancel because these three things are all multiplied together and this 0 is gone, right? So it's just ln of 3 over ln of 3, and we're left with 1 plus x ln of 3. And that's what our dy dx equals, okay? Assuming y was log base 3 of 1 plus x ln of 3. Just like that. Okay, and there's your answer. All right, I'm gonna leave the next ones for you to try because I don't want this video to be too long, and you need, some time to practice. So try these two and then check out the notes to see how you did, if you got them right, and if you have any issues, just let me know. Next is some old logarithmic rules. Make sure that you are still familiar with these if you need to go back over them again, and just make sure you know them, okay? Be very careful with them and make sure you're good with them. And then what we're going to get into now is logarithmic differentiation. So this is the idea that we can actually simplify what we have here and do a derivative with the logarithm. Now this doesn't always work. You have to be careful when you do this. But basically what we can do is we have some crazy complicated thing like this. You could go through and do this with all our quotient rules and product rules and stuff. But let's take a look at what happens if we take the natural log of the entire thing. And remember, x here has to be greater than 1. So we're going to get the natural log of y equals the natural log of x squared plus 1 times x plus 3 to the 1/2 over x minus 1, all right? And so what's going to happen is we can now split this up according to our log rules, our product and quotient rules, these two right here. The sum of the two things, or I'm sorry, where it's multiplied together here in the numerator, that's just this rule. For the denominator, that's this rule. So what we can do is just say that this equals, okay, it's going to be equal to the natural log of x squared plus 1 plus the natural log of x plus 3 to the 1/2, right, minus the natural log of x minus 1, okay? Still have natural log of y here, but now we can do a couple things like this 1/2. We can bring that out front. And so this becomes natural log of x squared plus 1 plus 1/2 times the natural log of x plus 3 minus the natural log of x minus 1. And now we can just do our implicit differentiation. So the derivative of the natural log of y is 1 over y, chain rule, times the derivative of y. And then we can do it here. This is 1 over, so this is just the derivative of just this part. Maybe I'll color code it for you, hold on. This is going to be 1 over, right, that's this one right here, 1 over x squared plus 1 times the derivative of what's on the inside, that's this part, that's a 2x, and the derivative of 1 is 0, that's that part, and then times the dx, right, which is just going to be 1. Whether or not you write that or not is up to you, the dx part. All right, let's go for the next part. That's this. Let's do the derivative of it. So plus, we'll have our 1/2 right out in front. We'll do 1 over x plus 3, that's the derivative of the natural log part, times the derivative of what's inside the natural log, the x plus 3 part, which is just a 1, times the derivative of x with respect to x, which is just 1 as well. Then we've got the last part. Let's pick one more color here. We'll do this. Don't forget the minus sign, minus, and we're doing this. Natural log of x minus 1, we do the derivative of the natural log, 1 over x minus 1, times the derivative of what's inside the natural log, which is just the derivative of x is 1, and the derivative of minus 1 is 0, so this is just 1 minus 0, which is 1, and then the derivative of x, dx, if you want to write that dx part or not, because it just goes to 1. Okay? And so what we end up with here is multiply the y over to both sides and do some simplification. Dy dx is just going to be 2x over x squared plus 1 plus 1 over, and I'm going to distribute that too, so 2x and 6, 2x plus 6, and then minus 1 over x minus 1, and then all times y, because I multiplied this y over to the other side, this y right here, multiply it over to the other side, okay? We also now remember, of course, up at the top, we know what y is, right? Don't forget to do that. If you know what y is, put it in. This is y right there. So this is going to be, I'm going to just grab this real quick, copy it, paste it. If this is going to be faster or not. And then I'm going to get that y, and I'm going to write this y from up here, what it was. X squared plus 1 times x plus 3, that was a very bad 3, to the 1/2, all over x minus 1, just like that, okay? And then that's it. There's your answer. Okay? And you can pretty much just stop there. All right? So after this, we just have a few little rules here. Just some final little things. For any x greater than 0, and for any real number n, x to the n equals e to the n times the natural log of x, okay? That's essentially from the idea that we're just going to raise this and make this e to the natural log of x to the n, and then move that out in front, right? So this is e to the n natural log of x. So that's a good one to keep in mind that you can do. So be sure you're paying attention to that. And then you go ahead and try this derivative of x to the x for x greater than 0. And then the last thing is that any number e can be calculated as the limit of, or not any number e, the number e, epsilon, is the limit as x goes to 0 of 1 plus x to the 1 over x power. And you can try this if you want. Start putting in numbers for x that are smaller and smaller, and you'll start getting closer and closer to that 2.718 something for e. This actually, I believe, comes from deriving this from compounding interest, where x is x basically ends up becoming how often you compound the interest. Are you doing it once a year, twice a year, 10 times a year, until you get to the point that you're doing it an infinite number of times a year. So I guess x is proportional. I guess it would be x is inversely proportional to the how often you do it. If you go to infinity for your compounding interest, you're doing it instantaneously, then x would go to 0, goes the opposite way, okay? But basically that's where that comes from. If you're really interested in it, we could probably find some videos or something for you that show it. There's a bunch of them, I'm sure. So, all right. So again, give this a try, give those problems a try, check back here, and make sure you're able to get them right. All right, that's all. Thanks.